Hey everyone, and welcome to Season 2, Episode 2 of the Christians in Culture podcast. So good to have you with us, whether you're watching on our Facebook page or listening in your podcast app of choice. It's great to have you with us. And if this is the first time you're hearing us, a very warm welcome to you. Maybe a friend or a family member has shared this episode with you because they thought it might be of interest. Well, my name is Rohan, and my wife Jill and I are lead pastors of C3 Church Camden, Picton and Thirroul in southwest Sydney and the Illawarra region, and it's great to have you with us. Hey, if you want to check out our previous episodes, you're very welcome to do that. Season 1 was recorded in the back half of 2019, pre-COVID, before the craziness of the last couple of years or so, and then we took a hiatus last year simply because everyone was scrambling to find our feet in this COVID culture. And so I really felt to resurrect Season 2 in the back half of 2021 now as we're starting to find our feet, and we're looking at what the future looks like for how to be a Christian essentially in a COVID culture. There's a lot of polarization, there's a lot of anxiety, there's a lot of stresses, there's a lot of uncertainties in this COVID season that we're in now. And I want to look at how we as Christians can represent Christ well, how we can bring his kingdom to earth, how we can most effectively serve our community around about us, how we can be Christians in a COVID culture. That's what Season 2 is all about. And in this episode and the next two to come after this, we're going to feature an interview that I had the privilege of doing recently with Lauren McKnight. Lauren is a member of our church at Camden. She has a PhD in immunology. She lectures in science in universities, and she also works for a not-for-profit that has a lot to do with immunology and vaccine research and all of that kind of stuff. So when it comes to this topic of vaccines, which is a quite a contested, confusing area, Lauren is a great resource for us to have. So what Lauren did in preparation for this interview is she put out a survey to her friends and family members, asking them to present whatever questions or concerns they or someone they know, or maybe one of their friends or family had, about the issue of vaccines. And we got over 90 responses to that survey. And so we got a good representation of probably the kind of people who will be listening to this podcast. And so there's a good chance that over the course of these episodes, we're going to address the questions that you or someone you know have as well. And we were able to take all those questions and break them down into categories and subcategories. And we're fairly confident that Lauren was able to address pretty much every question that someone asked, which is a good chance it's addressing the questions that you might have. Now, there was a lot to talk about. Our interview went for 2.5 hours. Yes, 2.5 hours. And I didn't want to bombard you with 2.5 hours all in one. So what we've done is we've split our podcast into 3 episodes, this one and the next 2. And in each of those, we're going to address a different aspect of the questions that came in. So in this first episode, we're going to look really at the vaccines themselves, at immunology. So a bit of history around immunology, how it works, the science of immunology, and how our vaccines work, and especially dealing with issues of the COVID vaccines. And then in episode 3, which will be the next episode, we're going to look more into the issues and concerns around the side effects of the vaccines and how can we be sure that they're safe and safety and so on. And then in the final episode, we're going to look at who we can trust. Who do we trust when there's so much competing voices coming at us? So that's really our next 3 episodes, and we're going to release these 3 days in a row, so you're going to get to these fairly soon. Well, without further ado, let's get into this first introductory episode all about vaccines with Lauren, and I'll chat with you afterwards. Well, hey everyone, and welcome to the Christians in Culture podcast. And with me today, I have Lauren, who is going to share on a really, really important topic, the topic of vaccinations. And unless you've been living under a rock lately, you would be well aware that this is a confusing, somewhat confusing topic at times. There is all kinds of differing opinions. Some say misinformation circulating. And so really, we wanted to take an opportunity to hear from Lauren, who is really what I would regard as an expert to a high degree in this situation. And so I believe that she's going to be of great help to us. So welcome, Lauren.
Hi, thank you so much for this opportunity, Rohan. I really appreciate it.
Pleasure. I'm really looking forward to your conversation. So before we get into the questions that we've got, and we've, you've been able to put together a really good survey, why don't you just tell us a little bit about yourself? Obviously, there's sensitivities around speaking for your employer and all that kind of stuff, and I totally get that. But why don't you just tell us a little bit about yourself and your interest in this area, and also your training in this area?
Yeah, sure. So I did a science degree out of uni and then ended up doing a PhD in immunology. My PhD was around allergies in particular and looking at the way that our white blood cells respond to different proteins in our environment. So not specifically to do with vaccination and infectious disease, but certainly those very confusing principles are ones that I have my head around. From there, I did some teaching at a number of local universities, and which I continue to do as well. And I also work for a medical research institute, and I work there as a kind of in a science communication education role. And so that's brought me, to the wonderful world of things like mRNA and lots of difficult genetics type concepts, and really just looking for ways to be able to explain and teach those well. So yeah, I kind of feel like that has put me in a place where I can understand some of the different confusions and different concepts that are floating around, and really just passionate about helping people to sift through that information, to understand things that are confusing to them. So as you can imagine, I have had many messages from friends lately asking me, different rumors or concepts that they've found difficult, or that, maybe their families are conflicted about. And it's always an honor to be able to speak into that and to help them find some good information and to really be able to wrestle with that alongside people.
Fantastic. That's I love your heart too, and having had conversations with you in preparation for this podcast, I know your heart is to bring truth and bring relevance and not bring judgmentalism or criticism, and I think that's the way forward. I mean, we were talking the other day saying that, on any topic, and vaccination is one of these topics where there will always be people who we're not going to see eye to eye with, or people who just are convinced that, that it doesn't matter what you say, but as an expert, there's going to be concerns there. But we really wanted to target, as is the case with this podcast, I'm really passionate about trying to target and provide solid perspectives and viewpoints to those that would consider themselves in the middle ground. Maybe those people who are hearing stuff or they're not sure, or they've got family members themselves that have expressed concerns, and they would go, well, I'm no scientist, I don't really know who to believe, I don't know who to trust, what's the story there? And I guess that's where I was really thought you'd be an ideal person to have, because you can bring that balance, you bring that you're not condescending in any way, so you bring that graciousness to the conversation, but you also bring that expertise to the conversation as well. And so in line with that too, I just thought I'd give a bit of a disclaimer. So as a C3 pastor, I'm talking about vaccination, and I'm aware that even within our own locations, there's people who will have different perspectives to me, and I just want to reiterate that I'm okay with that. We do not legislate on what people should or shouldn't believe or anything like that. But at the same time, as well as believing that, it's worth saying that I'm double vaxxed with Astra now, and I'm advocating the people. I'm for vaccinations, but not to the extent of having to legislate vaccinations or anything like that. But I've gone ahead, and both Jill and I, and pretty much all our family are vaccinated or in the process of getting vaccinated now. So that's where we're coming from. But I say that as a bit of a disclaimer, because one, I'm not speaking on behalf of C3 Church Australia or the C3 movement. Anything I share tonight will come from my thoughts, and at the same time, at times I may play devil's advocate, for want of a better term, with you, Lauren, and kind of poke and prod a bit from someone who might have a different perspective, so that you can be stimulated to ask those questions, answer those questions. But so I'm coming from that perspective. I'm not representing C3 Australia, and I just wanted to make that disclaimer. And it'd be the same for you. You're speaking. I think you've decided probably wisely not to say who you work for, and that's totally fine too. This is you speaking as Lauren, isn't it?
Yeah, absolutely. Yeah, and it's kind of a bit of a bittersweet moment where you have to make those sorts of disclaimers. Obviously we're always speaking as individuals and being aware of our individual worldviews and yes, things that might contribute to that. But I do think the level of polarization and division in the community around this issue is disappointing. And I would always hope to, I guess, be bypassing some of those, cultural or identity labels that we might try and put around some of these things. Like, health should be something that we can all bipartisanly, without needing any sort of tribalism. We should all be able to access good quality information for our healthcare. It worries me that that's not always the case. It worries me that there are, being political lines drawn around this sort of stuff. I think that's really disappointing. And so I hope that in this conversation we can put all of that aside and just look at, the things that we really do all agree on, is that everyone should have access to the best possible quality healthcare that they can.
Great thought. Well done. It's fantastic. I wanted to read just, you sent me in preparation for this podcast, you sent me a letter to a friend of a friend. And there's a bit in there, without going into any details, but there was a bit in there that I really struck, and I thought this resonates with the issues at hand over this topic. And they resonate with I believe your heart for people. And so you were talking about the fact that generally people want to fight for what's right. And let me just read what you said. You said, people want to fight for what's right. The problem is, what does that fight look like? Who do we hold responsible? What is the alternative to the way things are now? The answer to that question depends upon your worldview, which you just said. Worldviews are amazing things. They are, by definition, a social construct. Each of us shapes our experience through the lens of our relationships, our prior experiences, and what we see, read, and hear. There is so much variety in worldviews, and therefore so much variety in the way people have responded to the pandemic. It's also really important to recognize that the pandemic occurred at a time when the developed world was already so polarized socially and politically. We were already so distrustful of the media, the government, the elite. We were already angry. Worldview versus worldview was a battle that was already raging. A global pandemic has stoked the fires of distrust, resentment, and polarization. So motivated to fight the injustices that we see and determined to find the information we need to protect our families, where do we run? Where do we turn? Some people are looking to news sources they trust, believing that all other news sources are biased. Others are looking on social media, keeping an ear out for glimpses of information that tell us who to blame and what to fight. When us humans feel out of control, we don't understand what is happening. Our brains try to protect us from discomfort by grabbing onto things that make sense. And once we find something that makes sense to us, we're going to hold on to it with all we have. The algorithms then do a really good job of feeding our confirmation bias. And before long, it's impossible to believe anything else. Everything will be filtered through our belief. And we build up a long list of evidence to support our position. Our brains make sure of this because it protects us from that uncomfortable feeling of not knowing what is going on. Then we join others who share our beliefs, further reinforcing that anyone who disagrees is ignorant, misinformed, or willfully malicious. There are plenty of others out there whose worldview motivates them to spin a certain story. Some are well-meaning, others are desperate for their own slice of the political or financial windfall and to profit from the fear of others. That is as good a definition of confirmation bias as I have ever heard. I'm going to do a whole different podcast on confirmation bias, but I loved the fact that you were saying it's about safety. It's about wanting to reinforce that safety there, Lauren. And I've been having conversations with Jill over the weekend and just wrestling with this issue. And I'm forcing myself to argue at the opposite side to the perspective that I have. And it is uncomfortable, but I'm finding that's a healthy way for me. And in doing that, I've actually found that it's created new questions that I've had to go and answer that I don't even think I was probably even aware of had I not put myself out there and listen to an opposing view or force myself to think, yeah, but what would they think about this argument? And read through social media chats on news articles. You sent me an article. I think it was one of the news articles you sent me. I was reading through the chats, the conversations afterwards, and I found myself going, some guy made some point that was, advocating for the vaccine. And I thought, yeah, great point. And then someone made a point that was advocating against that argument. I went, they've got a point too, So it forced me to think outside my confirmation bias. And I guess that's what you think is a healthy thing to do, is to be prepared to ask questions rather than just stick to our own worldview. Yeah,
absolutely. And, it's difficult. I mean, these questions are raising things like, I never thought that I would have a non-scientist friend send me a video in which two scientists were arguing about clonal selection theory, which is an immunological concept. I just never thought that would happen. These are not easy concepts to grasp, and suddenly they're being argued
out there in the public spectrum,
in the public sphere. And so it's very easy to be convinced that, someone's missed this very important piece of information, and suddenly everything is we're on unstable ground again.
Sure. So that's that safety issue.
Yeah. And so, we can't all be experts in epidemiology.
No.
Like for myself, where I tend to, I'll get right into the science, I am not an economist.
Right.
And so when it comes to my own home loan or income protection or things like that, I choose not to go and try and figure out the fine details. Instead, I go to someone who I trust. I find someone who has proven expertise in the field, and I say, tell me what to do and I'll do it.
Yeah, I love that, because that's a humility. That's an understanding that that there's lots of things you don't know.
Yeah. But also I know that I could be taken advantage of. It's like that mechanic thing, right? I don't know.
Yes, that's right. Yeah.
Tells me something has to be fixed, then what am I to do? And so I think that brings that principle of trust is so important, and having people that you can trust. That I think that's why my friends have come to me. They know me.
You've got a bridge of relationship with them that you
that's right.
have built trust. That's right.
And, people who may have listened to your podcast before know the way that you grapple with issues, and how reasonable, and how they know where your heart is, and so they can trust you. And so it's tricky. I don't think there's any easy answers there, but I do hope that we can be someone, this conversation can be a trusted place of information. A trusted place.
And I trust you. And I look for anybody that has got some level of training and is working in the industry. And I think, well, that's a good step forward. And if there's anything that is endemic other than a virus in our population at the moment, I am concerned that there is a lack of trust, and that build out in some of the questions that we're talking about. So before we get into those questions, let me ask one more thing. You've mentioned to me a few times that you're quite passionate about the intersection of science and faith. And it seems to me that, at times, and I've been raised in a young earth creation view and that sort of stuff, and I don't necessarily hold that anymore, but I was raised to think that anything that contradicted the literal interpretation of scripture, and much of modern science seems to do that to some degree, that therefore there's a lack of trust around that. And I know that you're deeply engaged in science, and yet that hasn't affected your faith. And I sense that's something you really want to be able to help people with, to realize that the two aren't necessarily mutually exclusive from one another. Is that right?
Absolutely. That's my passion. I was very fortunate to have a science teacher in high school who was also quite an incredible man, actually. He's Reverend veterinary surgeon and teacher, and Commonwealth Games shot put bronze medalist.
It's a big mix. Random mix, yeah.
So
you wouldn't want to miss him. You wouldn't want to cross him if he's obviously a big guy.
He was definitely a rock in my faith journey, in lots of ways.
Yeah, in lots of ways, yeah.
Look, he really helped me in that very early formative stage to understand that my faith and my science could be not just not at odds, not just that I would, I think what a lot of people do is just keep them in different parts of their head, but I have found in my experience that my science and my faith are very complementary, and they really do enhance one another. I could give you a very long list of resources.
I wanted to mention you're the one who put me on to the Language of God podcast originally, and that's been a great help to me, because I was wrestling with this. And if anyone is interested in that, I think that's a really simple. It's actually a good. You probably, if you don't know anything about science, you might struggle with it because it gets a little bit deep at times. But I still think it's fairly entry level in that sense of a person who's genuinely wrestling with some questions. Is that a good place to start in terms of a Christian trying to put the two together and see if they're not mutually exclusive? What else would you recommend?
Yeah, I think so. Also, the book on which that movement is based, which is called The Language of God, is written by one of my heroes in the faith, Francis Collins.
Francis Collins, yeah, absolutely.
Currently head of the NIH in America, which...
deeply involved with this very issue, isn't he?
Yeah, that's right.
That's right.
Yeah, his book is spectacular.
Yeah, it's a good place to start. The Language of God, the book or the podcast. I think you'll find that there's a very godly, gracious man who is probably one of the smartest scientists in the world, involved in everything. I mean, we wouldn't be having mRNA vaccines if it wasn't for his role in unrolling the, decoding the human genome. What's it called? What's the exact terminology for it? Decoding?
The Human Genome Project.
The Human Genome Project, yeah. So there's a person who, has had a significant role as a person of faith as well, deep Christian faith. So that's a good place to start. Right, well, let's talk a little bit about our questions, and we're just going to work our way through them. So for those that aren't aware, Lauren, in preparation for this and some writing she's doing, put together a simple survey with 3 questions. And in many ways, the 3 questions were pretty much variations of the same question, just to in different ways, just to kind of get a bit of an assessment. Lauren, do you want to just sort of explain what your thoughts were behind those questions and your intentions?
Yeah, sure. I think, often when we look at the issues, we tend to just think that our own experience is a good representation of what others are experiencing. And been doing a user experience course at the moment, user focused design.
User focused.
And really realizing that my understanding is not necessarily the same as other people's understanding. And so the principle there is always to just ask people, what are your experiences? What are you finding? What are you wrestling with? And so it was really fascinating experience. Thank you for everybody who responded.
Last count there was 92 responses this afternoon, I noticed. So that's a good test pool to work with.
Yeah, that's right. I mean, absolutely a convenient sample and a snowball sample. So we won't get into our, we can't call it a representative sample.
No, it's not a representative sample. No.
But certainly representative of, the people that that yourself and I are engaging with. And so there were definitely some very strong themes. So things that we knew were common concerns from a wide range of positions. And so we've used those to inform the questions that we'll chat from.
We'll work through. Yeah.
So hopefully that's helpful for people.
Hopefully that'll help. What we'll do is we'll actually timestamp them in the show notes, so that if you've got a particular question you're pertinent with, you'll be able to jump to that point. You'll be able to see that in the way when we edit it and do the final edit and so on, so that you don't have to read through everything, because there'll be or listen through everything, because there'll be quite a lot of conversation here. But what Lauren and I were talking about, we were really keen to try and cover everything. So what we've done is we've taken pretty much every answer and broken them into the subcategories. There's probably about 10 different main categories maybe, and each of those, some of those have probably got a subcategory, but we've kind of done it in a way that we can just work our way through those questions, and you'll be able to hear from Lauren in the area of her expertise on each of those questions. The questions were asked in such a way as, what concerns or questions do you have, or are you aware of family or friends having? So not everyone who's expressing concerns is doing it on their own behalf, and as Lauren said, these are probably indicative of the conversations that we were aware of. So the number one was to do with side effects by far, wasn't it? Most people wanting to know, what are the side effects, short term and long term. But rather than start with that, even though that was the top of the list, as we're sort of preparing, I thought it was better to backtrack a bit before that and actually talk about the process and the vaccines themselves, because an understanding of these particular vaccines, the vector virus vaccine and the mRNA vaccine, the terms that are being thrown around, and how they work, may actually then be able to go ahead and answer some of those concerns, or at least illuminate the conversation around some of those concerns. So from here on in, I'm going to largely ask questions. I'll jump in. I feel like I'm a little bit of an amateur on this. I'm a way amateur compared to you, Lauren, but I've got enough understanding that I can ask some questions. So let's talk about the the vaccines first. The first question that we want to deal with is the nature of these vaccines, the AstraZeneca vaccine and the Pfizer and Moderna vaccines. And they are different kinds of vaccine technology than what people have normally been asked for. In fact, question 2, it was actually near the top of the list. We had 19% of respondents. Lauren put together a list of what are your main concerns. And third on the list and fourth on the list, respectively, were how mRNA vaccines work and how they differ from others. And they had about 20% of people asked that question. I thought that was a priority. And secondly, how our immune response works to those vaccines. So could you give us some history and some understanding on those vaccines? And then I'll fill in with some questions if necessary, but I'll let you tell us a bit about them.
Sure thing. So I think that our immune systems are amazing. Let me just start with that. The complexity with which all our different white blood cells, it's a bit of a running joke amongst scientists about how immunologists just love to find new categories of white blood cells and give them acronyms as names. And so, you've got your TH1s and your TH3s and, all sorts sorts of...
Every time I watch something and see those, I just ignore the numbers and I just go, I've got no idea what they're talking about.
Yeah, that's right. So our immune systems are these incredible things. And what the vaccines take advantage of is this thing called immunological memory. And so what that is, basically, when our white blood cells are created, they are just basically randomized as to what it is that they are going to recognize. So instead of having to come up, basically the idea is to be able to tell what is something that is our own body and what is something that is foreign, outside, needs to be gotten rid of. That's the whole job of the immune system. And then to get rid of it if something foreign comes in. So the way that it does that is generate complete randomness, so we can react to anything and everything, and then to take out the cells that react to our own body, anything present in our own body. So what that does is it creates basically everything else. Everything that's not us, we're going to be able to attack. Now, that obviously, you can't have lots and lots of cells for every single different combination of proteins and carbohydrates that might come into our body, right? Sure. But you can have a couple. And so the first time we encounter something new that's not ourself, so the first time we encounter a new virus, let's say, for this case, those very few white blood cells that recognize that virus are going to get activated, they're going to start to multiply, and our body will then keep some of those around because we go, okay, well, we know that this responded to something dangerous, so let's keep that around. So next time we see that dangerous thing, we can attack it and get rid of it.
Take the book off the library and start and make it quicker. Yeah,
that's right. We know this thing, we can beat it, and so that's why that's why we get immune to things. Whether it's we've seen that we've had that infection before or we've been vaccinated against it. So what a vaccine needs to do is it needs to give your body an exposure to a part of the virus. I'm just going to talk about viruses here because that's
sure.
What
slightly
COVID
different
is.
Bacteria, but yeah, COVID, yeah.
That's right. So we need to show our body part of the virus in a way that won't make us sick, but in a way that our body goes, oh, that's a foreign thing, let's get rid of it, and let's remember that this is a thing that exists and that we'd like to be able to remember how to fight. So that then when the real thing comes along, we're ready to go, we know how to fight it. And I think one of the really big things that I would like people to understand is that this is how all vaccines work. They give an important part of the virus So sometimes they do that by basically inactivating the virus and putting basically the whole dead body of the virus in there and going, hey body, this is what it looks like. Sometimes they do that by combining the new virus with a common virus that scientists work with all the time, and that we call that a viral vector. It's just basically a transport. It's the truck that's going to get it in there.
Yep.
And tell the immune system, hey, this is something bad, but it can't make us sick. And then there's this new way of mRNA, and we'll come back to that. But that's the principle of vaccination. It's not like this is a brand new type of disease and we're coming up with a brand new way of treating it. It's really just new virus. We need a new vaccine. And so
I was doing some research myself, and I was intrigued to hear that there's been the earliest types of vaccine, for want of a better term, technology. I was reading back at like 1000 BC, they were trying to give people small doses of viruses. They had this figured out that if we could just expose them to a small bit, they'd get sick. I mean, that was long before the technology was there, but they understood this concept, obviously, that they can actually trigger something inside a person. Obviously, that's not an exact science, but we're not dealing with something that was created, someone come up with in the last 50 years, are we? This whole concept has been around for some time.
Yeah, that's right. And really, yes, COVID is SARS-CoV-2 is a particularly nasty virus. And it is new in that we haven't seen this particular virus before. But it's not all that different from existing viruses. It's very similar to the SARS virus, which we've known about for years. Yeah. It's relatively similar to other coronaviruses family. And, it's a virus. We know a lot about how viruses work. And importantly, we know a lot about how our immune response to viruses works.
Right.
To the very fine detail of exactly what a cell does when it encounters a virus. We can visualize that under microscopes, and we know what proteins are moving around the cell and where they're going and what instructions and signals. So there's an incredible amount of knowledge about the immune response to viruses and the immune response to vaccines.
Amazing. It's incredible technology. It's incredible science to think that you can think about what's going on and actually watch what's happening inside.
Yes.
Supercomputer, the human cell, really. It's a supercomputer, isn't
absolutely.
it?
It's like a universe inside us.
So much happening in there. That's right. Yeah. Every time I think I understand it, I watch something else and that goes even deeper, and then I just think, oh wow, I thought I had it figured out, and you just confused me all over again.
Oh, look, same. Because there are people whose entire careers are built around one particular process that one particular protein does in one particular type of cell.
Amazing. Yeah, and amazing.
You could never fit all that.
You could never exhaust that. Well, that should tell us something right there. That how are we to possibly think we're experts when people build their entire careers and write their PhDs on one protein in one type of cell? Yeah, that should tell us something. Yeah. So let's talk a little bit about mRNA, because that is obviously one of the concerns right now. It's a new technology. Tell us a little bit about. And it'll lead into this question around what we have, which is around the trials being rushed and all that kind of stuff. So maybe talk to us about the mRNA vaccines and the history leading up to this time and where we came to. Would that help to explain? Is that how you want to tackle this issue of the mRNA vaccines?
Yeah.
We'll talk about what they do.
Yeah, look, let me tell you a bit about how they work, because really the principle is the same as other vaccines. So when you're developing a new vaccine or any vaccine, what you want to do is get the important part. We call it an antigen. So an antigen is something that stimulates the immune response. In most cases, it's a protein. And we want to get that into our bodies in a way that triggers an immune response. Now, there's lots of different ways to do that, as I've mentioned. This new way that they've come up with, and they haven't come up with it in response to COVID. They've been working on this sort of technology for a long time for lots of different applications.
Since the 70s, I believe, is when it sort of hit a bit of a stalemate, but they've been looking at it since the 1970s. Is that correct?
Yes. I don't know of when exactly the first trial was, but
right.
Getting mRNA. I mean, it's something that we do in in laboratory systems all the time.
Yeah.
You know that you can put mRNA in and the protein will get made. I think some of the really important things to keep in mind when understanding what mRNA is. So really like genetics 101, right? So our DNA is all our instructions of how to make everything in our body. Really important. It's important that it doesn't get damaged because that's going to be the instruction that cell uses throughout its whole life, and if things go wrong, then it can cause things like cancer or stop the cell from functioning. So DNA is very important, and it's important that we protect it. And there's so many mechanisms within the cell to make sure that our DNA is protected. I usually, like, if you want to refer to DNA as like the blueprints, or the town that is the cell, all its very precious original copy blueprints are kept locked away in Town Hall. But when you want to actually produce something, you need the instructions over at the factory, you need to send. You basically need to photocopy. That's right. So you basically take a photocopy of the very important blueprints and send it to the factory. That's the mRNA. It is temporary. It is a short stretch, and it never goes backwards. It never goes. So it comes out of the nucleus, which is where the DNA is, and it goes to the protein making factory, and it doesn't go back again.
Doesn't go back. It dies after that, doesn't it? Basically,
that's right. Yeah, they're fairly short-lived.
Yeah.
And so you can introduce mRNA. The way you get it inside of a cell is just wrap it in a little bit of oil, basically a lipid particle, and that'll help it. That'll allow it to get incorporated into the cell. And our protein factories don't really care where the mRNA came from. They're just like, okay, this is mRNA. I'm going to make the protein that it codes for. And so if you stick in the mRNA that codes for a viral spike protein, then
it makes the viral spike protein.
It goes in and makes it.
Yeah.
And because our immune system, one of the things that it looks for to go, oh, hold on, there's something going wrong here, is mRNA that's outside of the cell. And so these vaccines are really clever because not only do they provide the instructions on how to make the protein, but they also give that signal of, oops, something's weird here. And so you combine those two things together, oh, there's something going on, and oh, new protein, and hey presto, you've got your immune response. It's doing exactly the same job that, say, a viral vector or a inactivated vaccine is doing. It's providing the antigen, the thing we want to learn how to attack, and it's providing the signal to initiate the immune response. We used to use things like aluminium. So the traditional vaccines use aluminium to sort of tell the body to initiate that immune response. It's called an adjuvant. But these mRNA vaccines, they don't need that.
They don't need that.
It's a two-in-one. So they're fantastic technology. And it also means that you can change the instructions because, these viruses, they evolve very quickly. And so you can just, type into your computer to change the mRNA that it's producing, and we can adapt the vaccines very quickly, make sure that our vaccines are keeping up with the virus. And so in that regard, they're very adaptable vaccines, and that's why they were the first to market, because they are so easy to adapt. There were already trials going on for mRNA vaccines for other viruses, but because they're such adaptable vaccines, they were able to pivot, as we've all been doing, pivoting for COVID. They were able to pivot for COVID very quickly and be first to market.
I guess theoretically what you were saying is that because of the fact that you're basically programming the mRNA, the theory would be that it would be much quicker because we're not having to take a virus, then attenuate that virus and grow it and kill it and grow it and kill it, and then to get it to a safe model, which is basically changing the program using the same truck to get it in there. And so theoretically, it can happen within a matter of days or weeks, as opposed to that long, drawn-out process. Is that the significant difference?
Yeah. Right. Yeah, just really what's a flexible technology to be able to use.
We keep the same delivery truck, and we just very quickly just swap out the package for another one.
Yeah,
that's basically right. Okay,
right, which is exactly what the viruses are doing.
Which is what the virus is doing when it's mutating, isn't it?
That's it. Yeah. You know, everything else is the same, but I've changed this bit, and now you don't know me anymore. I'm wearing a disguise.
That's exactly
and so,
right.
You know, we can follow that, and with the genomic sequencing they're doing on the virus means that they're really following its evolution in real time, and so
so they can act on it quickly when they need to.
That's right. So when they go, okay, a variant of concern, such as Delta. Okay, let's look at the code around its spike protein, and let's make sure that it's not going to be too different. No, look, our vaccines are still providing good protection. The spike protein, and that's the reason why they chose the spike protein to be the antigen.
For those that don't know, the spike protein is we've all seen the picture of the coronavirus particle. It's those little crowny bits that stick out the top, all over it, doesn't it? Little spiky bits. That's the protein.
Yeah, that's right.
Yeah.
So one of the reasons why you would choose the spike protein to be the one you teach the immune system to fight is that it's on the outside, and so that's going to be easy for those antibodies to get to. Antibodies are just one of the chemicals our body makes that binds with the thing we are recognizing and fighting, and so it's on the outside, it's easy to get to, but it's also important because it's the spike protein that is like the key that the virus uses to get inside
to lock into the cell. Yeah. Okay.
Yeah. So the particular part of our cell that it attacks, it needs to be able to bind with that spike protein, and so it's a part that the virus can't just change up really readily because it's a very important part, key to its infectiousness.
To how it actually attaches. So, all right, so let me put it in more layman's terms. You can tell me whether or not I've made sense of it or not, but just to cover up that whole theory around how vaccines work. So let's take this spike protein, for instance. So let's look at the possible ways a vaccine could be formed. So if we just look at the little spiky bit, we could take the live coronavirus and we could mutate it or allow it to, over a period of time, we could take it, and like they did with measles, that's how over a number of years eventually got it to the point where it wasn't as dangerous, but it was still a live virus. Yeah. And I believe they can't actually put it into immunocompromised people because they can still be affected by it. But basically it's a desensitized virus. So they could take that, and they could, over a period of time, make the coronavirus sensitive and desensitized enough that they could then inject that into a person. Their immune system would recognize that spike protein, and away they'd go. So they could do that. One, they could take a part of the virus, like a subunit. So they could actually just take out the spike protein itself, and they could inject that. I know I'm oversimplifying it here, and then the immune system would attach onto that. And they
would need some sort of a
carrier to get it in.
Something to activate the immune system.
So they use a truck to activate the immune system, and then it's there.
That's right. Yeah. If you just inject a protein, you'll actually teach the immune system to ignore it, and that would be very problematic.
That would be worse. Well, yeah. So you need to get it into the cell.
Yeah.
Is that what you're saying? Yeah.
Well, no. Say if you inject a dog protein or a dust protein, that's right. We do that to turn off allergies. Yeah.
Oh yes, of course.
Desensitizing. It's the opposite of what we want.
It's the opposite. You're trying to stimulate the immune system.
We want to stimulate the immune system.
Okay, perfect.
Teach it to fight.
Right. Okay, that makes sense. All right, so we've got that. We've got a dead virus, an attenuated virus, or a part of the virus, and then I guess with viral vector and with mRNA, we're doing something different with both of those. So in those cases, we're actually telling our bodies to create a version or something that looks like the virus. Is that correct?
So
we're not actually
injecting the AstraZeneca is not like that. So the AstraZeneca, it uses the basically the shell of a pretty standard cold virus. It's been modified in the lab. It's one that we use really commonly.
That's that monkey virus or chimpanzee virus, is it, that they're talking about?
Yeah, you'll see it in the ingredients, and it's like CHAD. They give it it's an adenovirus. That's been modified. Hi all. At this point in the recording, I got a little bit tripped up, so I've just re-recorded it and drawn a diagram for those of you who are watching on the video. So yes, as Rohan said, both the viral vector approach and the mRNA vaccine approach both get our cells to make the spike protein. And so this pretty much mimics exactly what all viruses do. Viruses can't replicate themselves, so they use our cells' machinery to make new copies of their protein and genetic material. So the diagram that I drew has 4 different cells. The first one shows what happens when a cell gets infected with SARS-CoV-2, so the COVID virus. Maybe it's a cell in the nose or the throat. The virus injects the mRNA, and that goes straight to the factories to make more copies of the virus particles that then spread throughout the whole body. The second one shows what happens when we get a cold virus, standard cold virus, in this case from the adenovirus family. When that infects our cells, adenoviruses, they are DNA viruses. So their DNA goes to the nucleus of the infected host cell and then gets turned into mRNA. And then again, the proteins are made at our little factories, and the result is a whole lot more cold virus. So adenoviruses, even though they do make use of our nucleus, they're not able to insert into our DNA. Only retroviruses can do that. So the next 2 cells show what happen to cells that get exposed to the vaccines. So, cells in the arm muscle, when it's getting all sore after our vaccines. So as we've already discussed, with the mRNA vaccines, so like Pfizer or Moderna, the mRNA is delivered in this little lipid bubble, and it goes straight to our protein factories, and the spike protein gets made. So it triggers the immune system, but there's no replicating virus. The final cell shows what happens with the viral vector vaccines, like AstraZeneca and the Janssen vaccine. These vector vaccine also, the goal is to get the spike protein being made. But it uses an adenovirus, so basically a cold virus, but one that's been modified so it can't replicate. And they include in it the spike protein gene. So when this gene goes into the DNA and gets turned into RNA, mRNA, then it comes out and again goes to the protein making factories to produce the spike protein. So for all the vaccines, the idea is we want to get the spike protein made, get the immune system switched on, but importantly, there's no replicating virus, and so we don't get really sick. So where we start back the conversation, we're just talking about how these vector viruses and the mRNA viruses are not retroviruses and can't write into our DNA.
One of the questions that specifically came up, and I've heard a number of times, is with this new mRNA technology, the concern is, well, actually, it's rewriting our DNA. Now, you've explained that doesn't happen. Do you want to elaborate on that a little bit as to the possibility of that?
Yeah, look, I think it is confusing because, there are some viruses that they have mRNA in them, so they have this photocopy version, but they are designed and they have machinery that when they get into the cell, they actually proactively break into the nucleus, and they have machines, little tiny molecular machines, that use their mRNA code to write into our DNA. And so some viruses can do that. And that then means that some of these viruses can cause cancers or cause, depending on where they insert in our DNA, it can be really problematic. That is new. It is the first,
and that's the first
mRNA vaccine that's been approved for market. So it's a new approach because our understanding of genetic technologies and our ability to work with this sort of genetic material in the lab has just absolutely accelerated in the past, say, 15 years. And so we're at the point now where we can very readily give a cell some mRNA and have it be produced. And so, yeah, it's really just another way of getting a protein into a cell. And then that's what we want.
It strikes me that despite the fact that there's all this uncertainty around it, I tend to look at it the other way and think, had we had COVID-19, had it been COVID-09, we wouldn't have had this technology 10 years ago to do this. We wouldn't be able to generate these vaccines. So,
and look, we would have been able to generate other types of vaccines, certainly not this quickly.
Yes, yeah. And it's more moving forward now. Theoretically, we've got a technology that could enable us to adapt to any future virus much quicker than we've previously had. So would it be fair to say that the technology potentially has ethical implications in that if in the wrong hands it could be used that way, or is it not possible?
Not this technology. This technology, it doesn't have that machinery. You need very specialized machinery to be able to do that. And they're looking at that. Why would we ever want to do that? Well, what if you could
eradicate all kinds of
genetic disease?
Okay, yes, that's right.
This is called gene therapy, and it is very difficult. These sorts of gene, if you wanted to insert something that changed the DNA of the cells, I don't think it would be so much controversial, because you'd only be doing it in a specific location. You're not changing your DNA in your whole body. It'd just be, in the organ of interest. Right. But there are still big safety concerns to be overcome, because if you're making a change to the DNA of a cell, you have to be incredibly careful. There were some early successes and then some early disappointments where they caused leukemias in some cases. And so that's a very different technology, a very difficult technology.
That's actually really good too, because I think that's one of the concerns people have. And to be honest, I didn't know the answer to that either. I knew that viruses can rewrite DNA. So aside from scientific concerns such as it could cause cancer, it also does have ethical concerns down the track if we go down that path, because you could eradicate an ethnicity, or you could eradicate, there are all kinds of theoretical complications or ethic issues that could have to be taken into account. But that's not the case with mRNA.
Right. We're like multiple steps away from that, because if you were going to run into ethical concerns, then you're talking about what we call germline gene editing, so changing the heritable parts of the DNA. So not even all gene therapies do that. Right. And really importantly, the COVID vaccine is not a genetic therapy.
Right, absolutely.
It doesn't have that technology. The COVID virus, the SARS-CoV-2, it doesn't have that machinery to break into the cell, into the nucleus. It doesn't have the machinery to turn mRNA into DNA. That's not something.
That's not that. Okay, well, that's good to know. There's a good measured answer to that. I was surprised to hear. I don't remember all the stats exactly, but out of the 3.2 million base pairs, I was surprised to hear that like 200,000 of those are actually viruses that we have over time interacted in our body. So the question is, who are we really? We are partly virus, aren't we? We have
so not so much over our own personal history,
but
over
human history.
Deep history. Yeah.
Yes, that's right.
And if ever you want an answer to why are there viruses, they were essential for the building of the human genome.
Well, that brings us to the close of this first episode in our 3-part mini-series on vaccines. I hope that it was helpful for you. Our next episode coming up, we're going to be discussing all the concerns around side effects. So I look forward to talking to you then.